This is the second part on the chapter on tangent and secant properties. Okay. Before I tell you the property, you have to know something called alternate segment. Okay. Look at this figure. This line is the tangent to the circle. If this is the tangent, it touches the circle at A. A is called the point of contact. Okay. Now, from the point of contact, if you draw a chord, this is a chord. From A, there is a chord which is drawn to B. Now, when the chord is drawn, this whole circle is divided into two parts. This one, this part, and this part. Each of these parts are called segments. Okay. Now, again, if this is the tangent, this is the chord, there are two angles which are there between the chord and the tangent. I will mark one angle. One angle is BAQ. This one. That's the angle. Now, look at this. This angle touches the chord, it touches the tangent, which means it lies between the chord and the tangent. Okay. And this angle lies on the smaller segment. Is that right? It is lying on the smaller segment. Therefore, for this angle, the other segment, this one, is called the alternate segment. So, this segment is called alternate segment. So, wherever the angle is lying, that is not the alternate segment. Opposite to that is the alternate segment. Now, I have drawn the same figure again. Same figure I have drawn. There is a tangent. Point of contact is A. From A, a chord is drawn. The first angle I considered was BAQ, between chord and the tangent. I am going to consider the second angle, between the same chord and the tangent. Okay. The angle is BAP, this one. That's the angle. In the previous case, I took the angle which was touching this segment. In the next case, I am considering the angle between the chord and the tangent in this segment. Because it lies in this segment, the other segment where nothing is happened, that segment becomes the alternate segment for this angle. For this angle, this is the alternate segment. For this angle, this is the alternate segment. Okay. So, that one is the alternate segment. Okay. So, that's about which is the alternate segment, because the next property is about alternate segment. Okay. So, theorem number 8 is, if a straight line touches a circle, if a straight line touches the circle, this is the straight line which touches the circle at A, and from the point of contact, this is the point of contact, from the point of contact, a chord is drawn. AB is the chord. Same figure. PQ is the tangent, A is the point of contact, AB is the chord. Is drawn. The angles between the chord and the tangent are equal to the angles in the alternate segment. The angles between the chord and the segment. Here it says angles, but I am going to consider only one angle. Say the angle between the chord and the tangent. Okay. This is the chord, this is the tangent. Angle between these two is this one. So, angle between the chord and the tangent is equal to angle in the alternate segment. This angle between the chord and the tangent must be equal to angle made by the same chord in its alternate segment. Now, if you consider, for this angle, this segment is the alternate segment. So, anywhere on this circumference, starting from here, anywhere on this circumference till here, the angle can be made. I have considered this is the angle. It should start from A, it should go and touch this circumference and go to B. This is the angle. These two angles will be equal. Okay. Angle made between the chord and the tangent must be equal to angle made by the same chord in its alternate segment. Alternate segment is this side. Okay. So, these two angles will be equal. Now, I have drawn the same figure again. Circle, PQ is the tangent, A is the point of contact, AB is the chord. Okay. Now in this case, in the first case I consider this is the angle between the chord and the tangent. In the second case I am considering this is the angle between the chord and the tangent. Now this angle between the chord and the tangent must be equal to angle made by the same chord in its alternate segment. So for this angle, this is the alternate segment. So this angle can be made anywhere from B on the circumference till A. Anywhere it can be made. I have just considered this angle. So these two angles are equal. In this case, this angle and this angle are equal. In this case, this angle and this angle are equal. It's from the same property. Next, exercise 18b, question number 1. In the adjoining diagram, the diameter AB of a circle is produced to a point P. AB is the diameter. This is produced to a point P. P is outside. And PT is a tangent. P to T, this one, is a tangent. Given that angle TPB, TPB, this one is X. And angle TAB is 2X. Find angle BTP. This one you will find. That one. First one is BTP in terms of X. You don't have to find exact value. You can leave the answer in terms of X. So this is what you have to find. Now, look at this angle carefully. See what all it touches. It touches the line which is above. This is called the tangent. And it touches the line which is here. And this is called the chord. So this is the angle between chord and the tangent. Angle between the chord and the tangent must be equal to angle made by the same chord in its alternate segment. This is the angle. This angle and this angle will be same. Okay. So if this is 2x, this also must be 2x. Statement for that. First one, angle BTP, that is this angle, must be equal to angle TAB. Reason? Alternate segment property, that's the property which we saw before this. Okay. So BTP is equal to TAB is 2x. That's done. The second question is, you have to find the value of x. X is here, x is here, x is here. Okay. You have to find how much is x. Okay. For that, what I am going to do is, look at this triangle, ATP. In ATP, you know A is 2x, you know P is x, you know for this angle, the third angle, you know only part of it. This angle is not known. Okay? But if you look at this figure, this is a semicircle and angle in a semicircle is 90. So this angle must be 90. Now look at your triangle. See whether you know all the angles. 2x, x, 2x and 90 together. If you add all of them, you should get 180 degrees, sum of angles in a triangle. So our next step is finding the 90 here. Angle ATB is 90 degrees. This one is 90 degrees. Reason? Angle in a semicircle. After that, you consider this triangle and add all the angles, all the three angles. Angle TAB, this one, plus ATB, only this much, not the full angle. Then this BTP, that's 2x, plus TPA, that's this. All added together should give you 180 degrees. Sum of angles in a triangle. TAB's value is 2x, ATB is 90, BTP is 2x here, and TPA, the angle outside, was x. All added together is 180. 2x plus x is 5x is equal to, shift this 90 that side, 180 minus 90 gives you 90. So x is equal to 90 divided by 5, that gives you 18 degrees. Next question. In the given diagram, PQ is the tangent at P. This is the figure given. PQ is the tangent touching at P to the circle. Write down the sizes of the angles marked X, Y and Z there are two angles which are also known. This is 35 and this is 25. Okay. Using these two angles, you have to find x, y and z. The possibility is you can find y. Look at this. This is the tangent, this is the chord, and this is the angle between chord and the tangent. Angle between the chord and the tangent must be equal to angle made by the same chord in its alternate segment, that is y. So y must be equal to 25. So our first step is y is equal to 25, reason alternate segment property. Okay. Second one, we are going to find x. You found y. Okay. Y was 25, so this is 25. Look at this triangle. In this triangle, you know this angle, one angle, you know the second angle, you can find the third one, that is x. So add all the three angles, that should give you 180. So x plus y plus 35 is equal to 180 degrees. That's sum of angles in a triangle. X you don't know, y is 25 plus 35 is equal to 180. So x is equal to 25 plus 35 is 60. Shift the 60 that side. 180 minus 60 is 120 degrees. So you got x's value, that's 120 degrees. Only thing left now is z. Okay. If you look at this figure, this one, this is a cyclic quadrilateral from the previous chapter. This is a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary, which means this and this, if you add, you should get 180. So our next step is z plus x gives you 180 degrees, opposite angles of a cyclic quadrilateral. Okay. So z plus x's value is 120 is equal to 180. So z is equal to, shift to 120 that side, that gives you 60 degrees. Okay. So that was the next. Then question number 8. In the adjoining diagram, AD is the bisector of angle BAC. There is a circle. It says AD is the bisector of angle BAC. Angle BAC, this whole angle was 64. Okay. But AD is the bisector. This line AD bisects this angle. If it bisects this angle, means it divides the angle into two equal parts. Okay. Which means this angle is 32. And the remaining angle is also 32 because the total is 64. If BAC is 64, that one, and ACB is 31, this one is 31. Calculate angles. First one, TAD. This whole thing you find. TAD. But look at this angle. This is the whole angle. Part of it you know is 32. This much is 32. The remaining part you will find. Now look at the remaining part. The remaining part touches the chord and the tangent. The angle between the chord and the tangent is equal to angle made by the same chord in its alternate segment. That means this must be 31. So this angle is 31. So the whole angle TAD will be this much is 31. This much is 32, added together that will give you 63. So statement for that. Angle CAD, this much is 32. DAB is also 32, both are 32 because AD is the bisector. TAB is equal to angle ACB. These two angles, this angle and this angle must be equal because alternate segment property. So TAB is equal to ACB is 31. So now we have to find this whole angle which is made of two parts. So angle TAD, the whole thing is equal to, it's made of two parts I said, angle DAB, that this 32 plus TAB, this much, that's 31. Okay. So 32 plus 31, that gives you 63. Then, there are a few more questions. First one you found. Second one you have to find angle TDA. TDA. This one. if you look at TDA, this one, and this triangle is ACD. For ACD, this angle which I marked just now is the exterior angle. Exterior angle is equal to sum of opposite interior angles. Again, to get this, you add this 32 and this 31, that will give you this. Okay. So that will also be 63. Okay. So statements of those. For the second one, angle TDA, what we need to find is angle CAD plus ACB. Exterior angle is equal to sum of opposite interior angles. So TDA is equal to, this was 32 plus this is 31. TDA is 63 degrees. Now, there was one more question which says, after finding these and deduce that the triangle TAD is isosceles. TAD, this triangle is isosceles. Look at this. This one you got was 63, first part. This one you got also was 63. These two angles are equal in this triangle. If two angles are equal, then such triangles are called isosceles triangles. So I've just written a statement for that. Since angle TAD is equal to TDA, both are 63. You got 63 here, you got 63 here, both are 63. Triangle TAD is isosceles. So that's the last part. And your homework. Exercise 18B, question numbers 5, 6, 20 and 21.